All right, guys, so here is the solution of Vickrey auction or second price auction. Let's remember the theorem. In a second price auction, it is a weakly dominant strategy that each player bids his or her true value. So B of BISI equals SI. All right, so I'm going to prove this, but it may be helpful if you actually sort of build a very simple game, well, not a game, I'm sorry, it's a very simple, a matrix where you can actually sort of relate to what we are arguing here. Okay, so don't forget, this is a game with n many bidders or n many players, and each player has infinitely many types. And so the game is actually very complicated. So we can't really draw the game matrix and find the dominant strategy, equilibrium or dominant strategy. But so here's the trick I'm going to do. And so this table is hopefully going to help you realize what the heck we're doing here. So this is how we proceed. So I take just one player, right? Random, any player, doesn't matter. Player I's value, and we assume that his value is SI, or he received the signal SI. And SI is any SI in the interval S lower bar, S upper bar. Okay, there's nothing specific about player I and SI. All right, so here the very specific assumption I make. Well, what if this bidder bids BI something more than his true value SI, all right? What would be his utility here? What would be his utility here? I'm gonna compare them and show that bidding SI is no worse than bidding BI, regardless of what the other guys do. Because remember, a weakly dominant strategy means whatever the others do, I mean, do they bid their true valuation? Maybe yes, maybe no. I don't care, because dominant strategy, remember, says whatever other players do, I prefer to do SI rather than something higher or bidding something higher. Well, it's weakly dominant, well, because sometimes, depending on what others do, sometimes they may give me the same payoff, all right? But nevertheless, the payoff I'm gonna get by bidding SI is going to be never going to be less than bidding something higher than BI. Well, obviously you can say why BI is greater than SI. What if he wants to bid less than his true valuation? Well, we should also check that case as well, because this is just half of the proof. Okay? So, but stick it to it for now. So he bids something higher, strictly higher. Again, I ignore equalities throughout the proof because I know that it's a zero probability event. Trust me, it's not going to change our analysis at all. And so you shouldn't worry about it. So BI is greater than SI. All right. So I will use a special name for the second highest bid. I'm going to denote it by H. All right. So H denotes the second highest bid of the other bidders. All right, so basically H is the argmax Bj, J is not equal to I. Well, there are well, obviously player I doesn't know about H, right? So it's a random parameter for player I's point of view. So therefore there are three possible outcomes or scenarios that we should well, obviously there are infinitely many possible scenarios about the value of H, but we can categorize them into three classes from player I's perspective. So what are they? Well, you'll see why those three cases. The first case is when the H, the second highest bid, is in fact, I'm sorry, this is not the second highest bid. This is the highest bid of all the other players. It is higher than bid I, BI, and also SI. Remember, BI is already greater. We assume that it is greater than SI, all right? Well, H can be in between these two, right? So this is the second case. And H can be actually smaller than SI. All right, so there are three possible scenarios. All right, well, in the first scenario, Well, look at this carefully. Ignore everything else. Look at this scenario. So there is some other player who actually bids. So his bid is H, right? Because H is the highest bid of all the other guys. So there's some guy who makes a bid H, which is higher than my bid. So that means I lose. So in that case, if I bid BI, I'm going to win nothing. My payoff is going to be 0. So here, I just made a numerical example, all right? So SI is, let's say, 90, BI is 100. And here, I assumed H is 110, 95, 80. But you know what? Actually, yes, I know there are infinitely many other possibilities, but it doesn't really matter. I mean, for example, the case 60 is identical to 80, or the case 120 is identical to 110. All right, so because there are three sort of classes, I can categorize those columns. So here, this is the value of H, by the way. Yeah, this is my guy's bid versus, so this is his strategy. He bid 100, but his true value is actually 90. He could have bid 90. The question is he going to be doing better by bidding 100? Let's see. All right, so here this case says H is greater than and BI. So basically this column. Well, because he loses, player I loses, whether he bids BI 100 or 90, he's going to get 0 in either case. Okay. Well, what if the H, the highest bid of all the other players, H, was less than BI, what player I bids, but higher than SI? What would be the outcome? Well, here, because player I now wins by bidding 100 because he has the highest bid, if my sentences are not, or statements are not clear, please pause the video because they have to be clear, okay? When you calculate, you should be able to calculate this matrix by yourself. Otherwise, you can't really understand all the entire arguments. All right, so this should be your way of checking whether you're understanding the arguments or not. So here, when player I bids 100, given that the highest bids of the other players is 95, so he wins the object and pays what? Well, he's going to pay the second highest bid, which is 95. Okay, but what's going to be his utility? His utility is not 100. This is his bid. His valuation is 90 minus his bid. All right, so 90 minus his the highest bid, second highest bid, 95. So he's going to get minus 5. Okay? Well, what if he bid 90? What would be his payoff in this case? Well, in this case, because he doesn't have the highest bid, he would actually lost the object and so got a 0 payoff. You see, bidding 100 something higher than your true value is actually not better than bidding your true value. But we should also check this case. All right. Well, basically we are in the third scenario. What if H is even less than 80 SI? Well, in this case, both BI and SI would actually make you the winner, and the price that you would have to pay, regardless of your bid, whether it was BI or SI, would be H. Because remember, if you win, it doesn't matter how high your bid was. What it matters is the bid of the other guys. So H matters. H is going to be your price. So therefore, here, if you win when you bid 100, your utility, your payoff is going to be your valuation, 90, minus the second highest bid, which is 80. So you're going to get 10 utility in parentheses, okay? And here, well, the same thing. Your valuation is 90 and the second highest bid is 80. So therefore, you're going to get 10 utility. So you see what I mean? By bidding more than your true value, which is 90, is not going to make you better off. It is going to be either same for you or worse sometimes. So therefore, again, there are a bunch of different cases here, I know, regarding what value H can take, but all those cases are going to fall into one of those categories. And so I can say bidding your true value SI weakly dominates bidding something higher than your true value, which is 100 in this simple example. And it's weakly because you see sometimes both strategies are going to bring you the same payoff. Okay? So here, I hope you understand why I selected BI greater than SI. It really doesn't matter whether I consider 100 or 91 or 92 or 95 or 200. As long as BI is greater than SI, those payoffs will be the same. Okay, so you should also check that. So then what is next? Next is, what if my bid, what if I want to bid something less than SI? Okay, okay, I understand that bidding more than my true valuation is no good, but maybe bidding less than my true valuation is a good thing. Well, let's check. Exactly the same proof, by the way. Let again H denote the highest bid of all the other players, all right? And then there's going to be 3 possible scenarios from player I's perspective. All right, so let's erase those. Well, don't forget I have this time BI less than SI, right? BI less than SI, BI less than SI. So here's what I'm going to assume. First case, H is less than all. The second case, BI, H, SI. And then the third case, H is greater than all. All right? So here in this case, whether you bid BI or SI, doesn't matter. You win. Oh, by the way, if you like, you can BI this time is 80. Okay, if you need a numerical example. And let's first do the numerical example and then complete the proof. So here, when you bid 80, we already calculated those pairs, so you don't have to recalculate them. So here's another strategy. Under this strategy, what will be my payoff? Player I's payoff, I mean. Well, the other guy's highest bid is 110, so I'm going to lose, so 0. 95, the 80, so this is a poor choice. Let's make it 70. So H is less than, I never have this. Let me be careful. So H is greater than BI. All right, this is one case. And then H is between BI and SI. I will have to consider another case. Okay, let's think about it. All right, so let's think this BI 70. Okay, so what do I have? I have SI greater than BI. Yes, cool. But then what should I do? Well, H is less than BI. So I need something less than 70. So I need to look at another column here. So let's look at 60. Okay. So for the first case. And I need some H higher than 70 and less than BI. All right. Higher than BI and then less than SI. 98, 70. So this is 80. Very good. I have this case as well. And then I need H where higher than both BI and SI, 110 or 95. Both are okay. Good. So I need to consider this case. So you may wonder, why do I include this? So first, in the first scenario where I was looking at BI greater than SI, I didn't need to look at 60 because 60 and 80 is exactly the same. Why? Well, because both are less than BI and SI. So therefore, I can just put 1010 here. All right? However, when BI is less than CI, when I look at this category, well, I need to look at some other. So remember, the cases, possible cases, has now 3 different cases. And so I need another categorization. And for this reason, I needed to add just one more column. That's it, because those 4 columns are going to cover all those 3 cases and all the 3 cases we already considered when we were considering BI greater than SI. Okay, so 4 is going to be enough. But we can't have less than 4, so we need 4 for this reason. And so I added this column 60. Obviously there are a bunch of others, but all those others are going to be either the same as 60 column or 80 column or 95 column or 110 column. So they're going to be exactly the same of one of those 4. All right, so here, all I have to calculate this row, therefore. I don't need to calculate these, I already did. Well, so if the highest bid of the others is 110 or 95 or 80, bidding 70 is going to make you a loser, and so you're going to get nothing, all right? And then here, you can actually be the winner, and if you are the winner, remember your utility or payoff is going to be your true value, which is 90. Don't forget that. This is your true value. This is just a bid. This is just a strategy, another strategy you have. Instead of bidding your true strategy, you follow something less than that. So 90 minus the highest bid, which is 60. So you're going to get 30 utility. Okay? I'm sorry, I realized that I made a mistake here. So remember when I said the 60 column is going to be exactly the same as 80 column. It's going to be the same as meaning the bidding 90 is going to be greater than or equal to the payoff of bidding 90 is going to be greater than or equal to the payoff of bidding 100. But that doesn't mean that the values are going to be 10 and 10. That's my mistake. I am so sorry. These are not 10 and 10. I should have been a bit more careful. So here, if I bid 100 and the highest bid of the other players is 60, well, then I win the object. But don't forget, I don't pay 80. I pay 60. So therefore, my true valuation is 90 minus I pay 60. So I'm going to get 30 utility. 30 here and 30 here as well. Okay, sorry, that was an important mistake. So, but if you just look at this matrix, what you see is that again, all the other columns are going to be similar to those, all right? Meaning, for example, if it is 50, so let's check. So if it is 50, what's going to happen? So I am going to win whether I bid 100 or 90 or 70. So it's going to be the same as this column. So therefore, I'm going to get 90 minus, don't forget, my payoff is going to be 90 minus 50 because this is the highest bid. Highest losing bid. So I'm going to get 40 utility, 40 utility, 40 utility. Okay. However, if there's age where it's 200, okay, well then it's going to fall into this category where whether I bid 100 or 90 or 70 doesn't matter. I'm going to lose, and so 0, 0, 0. Okay. Pick another one. I don't know. 96. Well, it's going to fall into exactly this category, meaning I'm going to win here, I'm going to lose here, okay? But when I win here, what I'm going to pay is, when I'm going to receive is 90 minus 96, so it's minus 6, okay? And here I lose 0, 0, okay? So in that sense, those additional categories will be exactly the same as those columns. Not the numbers, but this greater than or equal to thing is going to be the same. So the bottom line is, as you see, bidding the true value is greater than or equal to, payoff-wise, bidding something higher or something lower. Okay? So when we come back here, let's complete this proof verbally. So in this case, whether you bid BI or SI, you win. Agree? And you win and pay age regardless. When I say regardless, whether you bid BI or SI doesn't matter. So therefore, both bidding BI and bidding SI is going to give you the same payoff. All right, so I didn't write that. Well, in the second scenario, let's look at the third scenario. Well, in this case, you lose regardless. Oops. Whether you bid BI or SI, it doesn't matter. You're going to lose and receive zero payoff. You lose regardless, get zero payoff. Here, regardless, get SI minus H payoff, which we know that it's positive. Okay? Well, here, however, you lose if you bid BI and get zero payoff, but you would have won if you bid SI instead and get SI minus H, which is positive SI minus H because SI is greater than I. So therefore, there are scenarios where bidding exactly as your true valuation is going to bring you strictly higher payoff. In other cases, you're going to get exactly the same payoff. So whether you bid higher or lower than your true valuation is not going to make you strictly better off, regardless of what others do. So therefore, bidding your true valuation is a weakly dominant strategy for player I whenever he receives signal SI. But there's nothing special about player I and SI. So therefore, for all players, bidding the true value is the weakly dominant strategy. I hope that was clear.